Hi, let's talk about the small signal equivalent model. As I said before, let's assume that in a particular diode, we have a voltage VD that is applied, okay? And this voltage comprises of two components. One is a fixed voltage of capital V, capital D, and on top of that fixed voltage you have a small changing voltage which is given by a small letter v small letter d. Okay, so what we are saying is, you can take a look at the voltage here. So you have a fixed voltage vd here, and on top of it you have a small changing signal which is given by this blue trace here. Now, if you look at the functioning of the diode, so this is the diode characteristic, right? Assume that we are very far away from zero, so there is an initial, initial zero current, and at point 0.7 the current starts to increase. We have expanded the scale quite a lot. So for this fixed voltage Vd, the current is going to be equal to Id. And as the voltage varies, so as the voltage varies from Vd, so it changes a little bit here, and then the point of operation is going to change from this point to this point. So the current changes, right? It goes to this point. And when the voltage goes below Vd, the current becomes this value. So what we have is, as we have the small signal changing, you have the current also changing on the diode, and that change happens on top of a fixed current which is id, right? So the change happens, so the average value of the current is id, which corresponds to the average value of the voltage that is applied across the diode. But then the voltage across the diode is changing, so the current through the diode is also changing. And if we just try to relate this change, okay, this small signal that is applied to the diode, now notice that it's not just the small signal that is applied to the diode. We are applying this small signal along with this large, what we call a bias, through on the diode. Okay, so, but let's say what we want to really relate is the change in id, which is this change, to the change in Vd. We can do that, right? We can do that by approximating this black line, this curve, as a straight line in this particular region of operation. Okay, and the slope of this line, let's say, is given by 1 over Rd. And um, if you look at the equations, and I have given the equations in the lecture notes if you are interested, you can see that Rd is going to be equal to Vt divided by Id, where Id is the average current that is flowing through the diode. Okay, so for this small signal that is riding on top of a large average signal, we can assume that the diode just behaves like a resistor. And this model is called the small signal equivalent model of our circuit. And in this case, the diode is just replaced by a resistor of Rd.